In this video, you will learn about how business data can be analyzed in various ways to give us useful information regarding businesses and what they must work on to have a better outreach. We have chosen a Yelp dataset which we downloaded from Kaggle, and in total there are 52 lakh user reviews and information on 1,74,000 businesses. We will focus mainly on two tables for our analysis, which are business table and review table. The attributes of business table are as follows: business ID, name, neighborhood, address, city, state, postal code, latitude, longitude, stars, review count, is open, and categories. Attributes of review table are as follows: review ID, user ID, business ID, stars, date, text, useful, funny, and cool. Let us move on to the exploratory analysis of our data. Let's check out the data set now. So here we have imported our data set, and we have dropped some columns which we do not find useful. We are keeping only open businesses and we are keeping only restaurants mainly, and we're choosing relevant columns that we have described in the attributes table. So this is our data set. So moving on to the exploratory analysis part, we want to find out the most popular reviewers. So for this, we are filtering out the number of reviews to be higher than 3, as 75% of the users have given at least 3 reviews and have more than 4 stars. So when we perform our analysis, we find out that there are 35,035 unique reviewers. So we want to filter these out based on a threshold. So we group by user ID and we find out the mean. We get the list and then we filter it out based on the stars. So for the most popular reviewers whose stars greater than or equal to 4, we find out that it is 21,074. But we do not want to find out which is greater than 4 because most 75% of users have given greater than 3 stars. So we want to find out the number of reviews greater than 3 stars. So we find out that there are 11,301 rows that are filtered out based on a threshold. So these are considered to be the most popular reviewers in this table, as you can see. Moving on, we want to find out the maximum number of restaurants in each city in the state of Arizona. So we have considered our state as AZ, which means Arizona, and the business city as well. So these are the cities and these are the number of restaurants. So Phoenix seems to be at the top of the list with 60,483 restaurants. And yes, this is for the state of Arizona as taken. Next, we want to find out the number of the highest reviewed restaurants and arrange them in descending order with the highest review first. So, when we perform our analysis, we find out that Pita Jungle has the highest number of reviews, that is 1,275. Next comes Oregano's Pizza Bistro, which is 960, and so on. Next, we move on to find out the geographical location of businesses. So for the geographical location, we are considering the attributes city, latitude, longitude, and the name of the business. This is the list, and we want to plot it on a graph as well. So we do some analysis and we plot it on our graph with latitude and longitude on our axes. And this is our result of the way restaurants are distributed in the state of Arizona with the latitude and longitudes. Next, we want to find out the cities with the most number of businesses in our data set. So we perform this analysis and we find out that the city Surprise in Arizona has the least number of businesses, which is almost nearing 0. And the city of Phoenix has the most number of businesses, that is around more than 60,000. So this is what we found out from the cities with most businesses. Moving on, we want to see if there is any relation between the number of stars or rating and the number of reviews. So we perform the analysis to see if there is any relationship between these two, and we find out that there is no positive correlation between these two as per the graph. And so, what deduction we can make from this is uh, it if a business has greater number of stars, it does not mean that it should have more reviews, or if a restaurant has more number of reviews does not mean that it should have a greater number of stars. So this is the deduction we get from this analysis. Next, we've dropped some rows with not a number reviews, and we move on to add a new column. And this column is called text length, and we it is to find the length of the review text. So why we do this is as follows: we want to see if the length of the review text has any relationship with the number of stars or the rating of a restaurant. So we have found out the total number of restaurants here. That is 2,339. And next we are finding out the top 10 restaurants with most reviews. These are the top 10. Now we are finding out and comparing the businesses with 5 stars, the top 10, I mean, the top businesses with 5 stars and the top businesses with 1 star. 1 star and 5 stars. So this is the result. We group them together and we take out the mean. So this is our result. Next, we want to find an overview of all the reviews that we have received in our data set. So we have taken into consideration useful, cool, funny, negative reviews, positive, and total, and we have printed their values. So this is our result. So these are our values of total, useful, funny, cool, and negative and positive. We want to take a look of it as a pie chart as well. So we perform some analysis over here and we get a pie chart format of the same. So we find out that the maximum in this is taken by the positive reviews, which is around 37.8%. And the next is taken by useful reviews, which is 26.2%. Next is by cool reviews, which is 16.1%. Funny reviews constitute 12.7%. And the least is taken by total negative reviews, which are 7.3% only. Next, we perform some statistical analysis on our data set. Let us take a look at how it goes. So, for our statistical analysis, to check if reviewers count and the text length have the same distribution, we perform some analysis. We want to see if there is a corresponding relation between the two. So after applying the KS test, we find the p-value to be 0, which is less than zero point 0.5. So hence the distributions are different from each other. This tells us that the reviewer review count does not increase if the length of the review is long. So as you remember, I had said that we had added a text length of reviewers review count. So yes, it says that it does not increase if the length of the review is long. That means if text length is long, the reviewer review count does not increase. And next, moving on, we've performed the KS test between stars length and text length. Again, the p-value is zero point 0.0, so they are different distributions as well. Next, we have performed the KS test for stars and useful. Again, our p-value is 0, so it states that they have different distributions. So we perform some analysis to get a pair plot because we want to confirm with the Gaussian test and find out if p-value is lesser than zero point 0.5. So this is our pair plot result. As you can see, all the graphs here. So from the Gaussian test, we can confirm that p-value is lesser than zero point 0.5. So hence, what we have made the deduction is true. It is p is zero point 0.0. So we also plot it as a graph. And yes, we have confirmed. Moving on, we have an overview of reviews and sorry, not an overview of reviews. Moving on, we have added another column to identify good reviewed restaurants. So as we had added another column to find the maximum to find the text length, we have added another column to find the good reviewed restaurants. So once we perform that analysis, we can see that it is a binary value, so it's either true or false. And a restaurant is considered to be good reviewed if it has more than or equal to 3 stars. So this is how this works. And we also find out the top reviewed restaurants from the same. We plot a histogram for the same based of the star ratings. So the pattern seems to be the same in all of the graphs. So we can say that the quantity does not matter, but quality matters finally. Next, we want to see the skewness. So we perform some analysis for the same, and we are taking box plot of text length for each star rating. And this is what we find out. So for 1 star, 2 star, 3 star, 4 star, and 5 star, these are the box plots. So skewness is as shown from the above histogram as well. And this is the box plot. Next, moving on, we perform Spearman's rank correlation as a part of our statistical analysis. Now, Spearman's rank correlation tells us that good reviewed restaurants and text lengths are probably dependent, and after coming, we will be confirming it with Pearson's correlation. So let's check out what happens. So we perform Spearman's rank correlation over here, and we got the result probably dependent. So next we performed Pearson's as well over here, and we got the value 0.81. So from here we can make a deduction that we can confirm from Pearson's correlation that they are positively correlated. Who are positively correlated? Good reviewed restaurants and text length. So good reviewed restaurants usually have greater text length in their reviews. So over here we're checking if longer reviews get useful votes, and we have found out that it is this. So here we've grouped the data by stars and calculated the sum of all columns, just some exploratory analysis. Similarly, we find out the mean as well for the stars. And then the most important, we plot the correlation matrix. So this is the text box, and down below we have the implementation of the same. So from here, from this correlation matrix, we can conclude a lot of statements. Let me list them out to you one by one. So our Yelp review analysis will be beneficial to the customers as well as owners of restaurants in making profitable decisions for their businesses. So from this analysis, we can see that good reviewed restaurants are usually clustered together in the same location or area, which attracts customer base for the restaurants. This means that if one of the restaurants is crowded or full, the probability of the customer visiting another restaurant around the same location is definitely higher. That is why we see that these restaurants in and around each other happen to be widely reviewed. Hence, the right location matters for a business to get more customers. This is our first conclusion. Our second conclusion is as follows. From the text length distribution graph for each rating, the distribution is found constant, from which we can infer that review shouldn't be quantified for analysis, but instead we should have some sentimental analysis performed on it to see the positive or negative impact of reviews on the business income or value. Our third conclusion is as follows. Good reviewed restaurants and useful are negatively correlated. That means reviewers find negative reviews more useful than positive reviews. Fourth conclusion, the text length and useful are positively correlated, indicating that viewers are more interested in longer reviews. Our last conclusion is as follows: text length and stars are negatively correlated. So, both of them have different distribution as we have found out from the KS test. So, it also indicates that negatively reviewed restaurants have longer reviews and viewers find that more useful. So, this is our exploratory analysis as well as statistical analysis. I hope I have explained everything properly. Next, we will be moving on to classification and regression. So, first, we shall perform some regression analysis. Let us take a look. So, as a part of our advanced analysis, we will first be doing regression. Under regression, we have taken into consideration linear and logistic, and we will be comparing the same. Let's begin. Here in this file, we are going to perform linear regression on our data set. With the help of this, we are going to find the attributes which are contributing towards opening and closing of businesses. So let us import all the necessary modules and load the data set using pandas. Let's see how many businesses are open and closed by using count plot. So this is our result. We find that this many businesses are open and this many businesses are closed. Now, for our regression model, we are considering business latitude, business longitude, business stars, and business review count to be our independent variables. That is, we are going to predict how much these attributes contribute towards the opening and closing of businesses. So we make all our empty values 0 and we will split our data set for training and testing. We have left 30% of our data set for the testing purpose and we have used SMOTE for sampling. So we fit our training set and we import our linear regression model. From this, we get the accuracy score of our values to be 0.5635. That means 56.35%. So, the above variables that we considered amount to 56.3% dependency on a business being open or closed. That is, collectively, all of these variables contribute to 56.35% for a business to be open or closed. So we want to also have a classification report for the same, which consists of precision, recall, and F1 score. Now, precision is a measure of result relevancy, while recall is a measure of how many truly relevant results have been found. We can also plot a confusion matrix for the same. So we got precision and recall over here and F1 score as well. Next, we are plotting the confusion matrix. So we get this as our answer. And the final accuracy score is found to be 0.5635 as above. Last but not the least, we want to find the contribution of each variable, that is business latitude, business longitude, number of stars, and number of reviews. So latitude and longitude does not have much impact. That means the location of the business does not affect whether it is open or closed. But the number of stars greatly affects the business to be open or closed because around 10.53% is its contribution towards the entire result. So we find that if the stars majorly impact a business to be open or closed, and this is the number of reviews, it does not, it very minorly impacts the business to be open or closed. So this is the linear regression we have performed on our data set, and these are our values. Next, we shall move on to logistic regression. In this file, we are going to perform logistic regression. We basically want to compare the results that we have achieved from linear regression and logistic regression as a part of our regression. So first we have imported our data set and all the modules necessary to perform logistic regression. So we have read our data set. We have also used count plot to see how many number of businesses are open and closed as stated in linear regression. So these many are open and these many are closed. Next, we are importing the independent variables for our regression model, which will be the same as previous one. That is business latitude, business longitude, business stars, and business review count. Then all the empty values are made zero. And this data set is split for testing and training. Again, 30% is left for testing. Smote is used for the sampling purpose. Now we will fit our training and testing set and make it as a data frame. Over here, L is the list which contains different regularization constant. For all these constants, let us apply logistic regression model and let us store all the accuracy values inside a dictionary. In this dictionary, key is regularization constant and values is respective accuracy score. So the maximum accuracy score we get is 55% for regularization constant being 1. Let us move further and calculate accuracy, precision, and recall for the prediction that we have made. We shall plot an ROC and AUC curve as well. So basically, AUC measures the performance of the model. That is, if the AUC is high, that means model's performance is good at distinguishing between the positive and negative classes. So we are visualizing the graph for C versus accuracy values. This is our graph. So as you can see, it is 55%. We can also plot a confusion matrix for the same to get the false positive, false negative, true positive, and true negative values. So we get our accuracy score to be 53.86%. In linear regression, it was 56.35%. And we get our contribution of each variable to be this. Over here, we have again stars are giving us 40.68% contribution for a business to be open or closed. So this is the final result of logistic regression. We can say that stars affect 40.68% for the business to be open or closed, and number of reviews do not affect that much. And latitude and longitude, that is location, does not matter as well. But the maximum independent variable that matters is the number of stars that a business has. Next, we will be applying classification as a part of our advanced analysis. We will be performing a prediction of user ratings given by the user to the business or services, provided the user text review is given to us. The algorithms which we are using for our classification is naive Bayes, random forest, decision tree, and KNN. So, on the basis of their accuracy, we shall compare in the end which one is best. Let us move on to seeing our data set. Let's start with importing all the required libraries first. Let's load the data and display the first 5 data entries. So the only two columns which are required in this loaded data is text and stars. So we have stars and we have text. Text column for getting the reviews, that is independent feature. This is the independent feature. And stars, which is the dependent feature. The raw text in the dataset needs to be cleaned and converted into numerical values in order to be able to pass it to the models for training and testing. And also predicting actually. So pre-processing on the text that is done is retaining only characters and getting rid of numbers and special characters, converting the whole string into lowercase, removing the stop words using those defined in the NLTK library. This step is done to get rid of the frequently occurring words and to train the most significant words in that sentence. We see that the stars column has 1, 2, 3, 4, 5 values, that is 5 different values of classes. So this shows that we need to implement multinomial naive Bayes theorem. So we shall split the dependent and independent features on our data set. For each class, we'll find the number of examples in it and the log probability prior. We'll also record the number of occurrences of each word and create a vocabulary. It is a set of all words we have seen in our training data. So we use tokenizer, which is here. Yeah, we use tokenizer and built-in class counter to convert a review of to a bag of words. So we use this to convert a review to a bag of words. Next, we are going to apply our multinomial naive Bayes theorem, our algorithm on our data. Over here, we are applying Laplace smoothing because we want to fix the problem which will be encountered when the probability of finding this word in that class will be zero, because it is possible for a word in the vocabulary to be present in one class but not in another. Now, to make predictions, we use the class prior and vocabulary. So, for each review, we use log priors for stars and tokenize the text as shown above. For each word, we will check if it is in the vocabulary and skip it if it is not. Then we calculate the log probability of this word for each class. We add the class scores and pick the class with the max score for our prediction. So this is our prediction module and we get our result here. We can see that the accuracy of naive Bayes model is just 40%. So we should move on to other algorithms and check their accuracy as well. In this file, we have tried to compare decision tree, random forest, and k nearest neighbor algorithm. With the help of these algorithms, we will try to predict user ratings given by the user to the business or services, provided the user text review is given to us. This is called as review rating prediction, and this has lately become a popular problem in the machine learning and data science field. Here we will be using NLP to make the prediction. So first let us start by importing all the necessary libraries and packages. We need to pay attention on the grid search CV library, which was initially a part of the grid search package, but now it is a part of the sklearn model selection package. Now let us load our data into the data set. We are going to see specific details like shape of the data set, column names, data type of each column, and few data set entries. So this is the shape of our data set based on what we have selected. Now let's create a separate column in the data set which will hold the number of words in a review. It can be referred to as word count or word length. So over here we have done that. Now let's compare the text length with stars. We have text length on the x-axis and number of reviews on the y-axis. Yes, there are less number of reviews for 1-star rating and more number of reviews for 5-star rating, but the word length distribution for all the categories is same, which means in every star category we have reviews of almost all lengths. We have reviews of word length 0, 1000, 2000, 3000 up till 5000, and we can also have 500, and we can also observe that reviews of word count 500 are more in each star category. So in our data set we have a section which is we where a review is voted cool, useful, funny, and the length is taken into consideration. So here we can see that we want to find the correlation between them. So here we can see that a negative correlation exists between cool and useful, cool and funny, and cool and length. And there is a positive correlation between funny and useful, funny and length. useful and length, which brings us to a conclusion that the review marked cool tends not to be funny, not very useful to others, and short. Long reviews tend to be useful and funny. Keeping this conclusion in mind, let us proceed further to classify the dataset into positive review, average review, and negative review. Here we consider that the review which has 1 star rating as negative. So this is our classification part. Now we will separate the data into X and Y for prediction, where X contains all the review text and Y contains all the review stars, as you can see here. Next, we will clean up the reviews and remove the stop words and punctuations. Stop words are often removed from the text before training deep learning and machine learning models, since stop words occur in abundance and provide little to no unique information that can be used for classification or clustering. Punctuations are removed to get a vector representation of the words. Then we proceed to vectorize the reviews written. First, we have tried vectorizing one review just to check that it works fine. As we can see that it is working perfectly fine. So all the reviews have been vectorized. The stopword package was missing, so we have downloaded and installed it. And word embedding or word vectorization is a method in NLP to map words or phrases from vocabulary to corresponding vector or real number, which is used to find word prediction or word similarity matrix. So the process of converting word into number is called vectorization. Now we will be splitting the data set into testing and training set. With all the pre-processing, cleaning and sorting work done with our data set, now our data set is ready to run the algorithms and do prediction. First, we will run random forest algorithm on our data set. Uh, so let us take a look at our random forest algorithm. This is our random forest algorithm. So we get our confusion matrix as well as classification report. So from here, we can find out that the score of the algorithm is 70.36, which is portrayed here. So we have the classification report which says decision for negative review is 0.97, and for the average review it's 0.70, and for positive review it is 0.70 again. Next we will be applying decision tree algorithm on our data set, and the confusion matrix is displayed over here. So this is our confusion matrix and our score is 64.59. And according to the classification report, precision for negative review is 0.49, for average review it's 0.47, and 0.75 for positive review. Next, we will be applying our last algorithm, that is k nearest neighbor algorithm, under classifications. So after applying this algorithm, we get the score from the confusion matrix as 61.35, with the procession of 0.52 for negative reviews, 0.60 for average reviews, and 0.62 for good reviews or positive reviews. When we compare the score of random forest, decision tree, and k nearest neighbors, we find that the random forest classifier has the highest score with 70.36%, which means this is the best suit algorithm for our prediction. But we have applied all the algorithms for the prediction to show it to you guys so that you can compare all of them and check all their accuracies. Now we will select a random review from the positive review and try to predict the rating. So this is a positive review we have selected, a random, completely random positive review. Now let's try to predict with an average. So what we have done here is we have the rating which is predicted by our algorithm, which says it is 5. So next we will take an average review, a completely random average review, and we will predict the star for it. This is our predicted rating, it is 3, and this is our actual, which is also 3. Up top, actual rating was 5 and we predicted 5. Next we have taken a negative review and predicted actual rating was 1 and our predicted rating is also 1. So the results displayed on the screen portray that our algorithm has done a great job by predicting correctly. Now let us proceed to our final algorithm and try to do the predictions. We will select a random positive, negative and average review, apply the KNN algorithm on this and try to do the prediction. So again, we have selected a random positive review. We found out that the actual rating was 5 and the predicted rating is also 5. Next, we by applying the KNN algorithm. Next, we selected an average review by applying decision tree algorithm on it. So our predicted rating is 3 as well as actual rating is also 3. Next, we applied decision tree on a random negative review, and we found out that the actual rating was 1, which is already there, and the predicted rating was 1. Next, we have applied KNN on a positive review to find out the rating and predict it. So the predicted rating is 5 and the actual rating is 5. Next, we have applied KNN on an average review again. So we see that actual rating is 3 and predicted rating is 5. So over here, KNN seems to not predict the right result. So we can say that KNN is not the most accurate, but still holds good for an algorithm to be run and predict. So let's see the negative review by KNN. So we predicted one more and we found that the actual rating was 1 and predicted rating was 5. So this is where our KNN also is going wrong. So that is why we wouldn't suggest to use KNN. So what we have observed is that the KNN algorithm has done the correct prediction on positive and on average review, but it has failed to do the correct prediction on negative review, and the results are again as shown above. So we saw that the KNN review was giving, KNN values for our reviews were not very accurate for the negative reviews. So we wanted to check why this error is happening. So we listed out the count of all types of data. Count of all types of ratings. On your screen, you can see clearly that there is more number of positive reviews and more number of positive and average reviews compared to negative reviews. Our data set is based towards the positive reviews. I think this would be the reason why the error was occurring in our data set while performing the KNN algorithm when we did this prediction. This problem could probably be fixed by normalizing the data set to have equal number of reviews, which would remove this bias. So this is the conclusion we get from our classification algorithms. We have applied naive Bayes theorem, random forest, KNN, and decision tree algorithm, with random forest giving us the best accuracy, that is 70%. Last but not the least, we will be performing a clustering analysis on our data set. We will be applying it 2 times on different topics. In the beginning, we will do clustering based on the number of reviews versus the star rating of each hotel, and we are going to be finding out which cluster has the highest reviews and the highest star rating. Then again, we will be performing another clustering analysis based on latitude and longitude. So with this, we will be plotting the geographical location of all the hotels. Let us take a look at our data set now. We have started by importing all the necessary libraries and packages, and we have loaded our data set. Uh, and some of the details of the data set are like shape of the data, column names, data type of each column, data set summary. And this is the displaying of our data set. Next, we will be creating a variable x with the reviewer count and stars. Here, we will be using the elbow curve method to determine the optimal number of clusters. So the x-axis will be star ratings and y-axis will be reviews count, and we will be getting the scores accordingly. So we have plotted the to determine the optimal number of clusters, where X label is the number of clusters and Y label is the scores which we have received, as you can see over here. After plotting this, we get the result that the optimal number of clusters we require is 3, as you can see here. So we use that, and we are going to be predicting the cluster label for each element which it belongs, and then we will be adding a column named as label in variable X, and we will display each business belongs to which cluster. So we have applied a k-means algorithm for the same, and this is what we have got. Next, we will be plotting the clustering based on reviews count of each business. Here we can see the plotting of three clusters. Now we will be performing a mean operation on each of the clusters to find the average reviews count and average star rating of each cluster. We can see that every cluster has an average star rating of 3.7. Next, we will be checking if each cluster can be distinguished based on star rating. So here we have performed the analysis. Since the average star rating is 3.7, so we will be checking the number of businesses in each cluster which has a star rating above 3. So here, as you can see, we have done that. And we will be getting the values of each cluster. Then we will plot a graph for each of these clusters. So we have got our values over here, and we have plotted the graph for the same. We have come to a conclusion. So please let's take a look at the clusters now. So we have come to a conclusion that zero cluster consists of highly reviewed restaurants and has higher rating. So the zeroth cluster is this over here. Next, we will be performing another clustering to find out the geographical mapping of each business using latitude and longitude. We will be creating a variable x with the business latitude and business longitude. Here we will again be using the elbow curve method as previously used to find out the optimal number of clusters, so that the x-axis will be the business longitude and y-axis will be the business uh, latitude, and we will be getting the scores. So once we have plotted, we have got the optimal number of clusters to be 3. So next we will be performing k-means operation with the number of clusters as 3, predicting the cluster label for each element which it belongs, and then we will be adding a column named as label in the variable x, and we will display each business belongs to which cluster as we have done earlier. So we have taken the cluster number as 3 and we have continued. Now we will be plotting the clusters with X label as business latitude and Y label as business longitude. We can see that the final geographical locations of all the businesses which is scattered into 3 clusters over here. So this is the geographical map of all the hotels on our data set, and these are all the analysis that we have performed. I shall give a small recap of what all we have done. We have done initially, we have started with our data description, then we have performed exploratory data analysis and statistical analysis. Moving on, we have performed some regression, that is two types, linear regression and logistic regression, and we have compared their results. Next, we have performed classification. We have used 4 different algorithms: naive Bayes, random forest, decision tree, and KNN, and we found out that random forest is giving the best results. Last but not the least, we have performed clustering by using k-means, and we have taken 2 different topics to perform the clustering on, and we have got the accurate results.